Hello, Math 120, and this is Professor Gonzalez, and I'd like to do some problems from homework section 9.2. Now, 9.2 is a section entitled Circles, and circles are part of the conic sections, and conic sections are basically conic or cones, and if you slice cones in certain ways, you can get four different conic sections: a circle, an ellipse, a parabola, and a hyperbola. But today we're just talking about a circle. So let me talk about the circle just a little bit. I know you're familiar with the circle because they've just been around us since we were kids so much. But let me just give you the formal definition in terms of a conic section. So the circle is the set of all points in a Cartesian plane that are a fixed distance r from the fixed point h comma k. The fixed distance r is the radius, and the fixed point h comma k is the center of the circle. So if I do a quick little picture of that, you've got a circle, and you've got this center. Center is called h comma k, and that is just the center. And then we have this distance that you go from the center to a point on the circle, and that distance, remember, is going to be the same anywhere. So I guess if you have this center point and you pulled out a string and you ran around the circle, you would have a circle, right? And that circle has a radius r. Okay, so that's our basic definition of a circle, right? That if you pull the string from the center out to any point on the edge of that circle, it would have that same radius r. Now, we have a standard form for a circle. I'm going to show you how we get that. So I've got my center, which is h comma k, and we also could have, let's say, a point, just some point p, which is kind of could be called x comma y. And so this equation of the circle actually comes from the distance formula. Remember the distance formula? The distance equals the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Okay, that's the distance formula. So we want to find the distance between the center and point P. Well, we already know the distance is r, radius. So I'm going to put instead of having the d on that side, the distance, I'm going to have r, which is the distance, on the right, just because it fits our formula a little better. And let's do the rest of this. What is the distance formula? Well, the distance r is going to be equal to the difference of the x. So I'm going to take x minus, and remember the x value of this center is h. And the distance formula says we must take the difference of those and square them. And then we've got our y value minus the y value of the center, which is called k. And then we go ahead and solve. Well, the standard form doesn't have a square root in it, so we can show that by just squaring both sides. And we have this form that's just x minus h quantity squared plus the quantity y minus k quantity squared equals r squared. And this is where h comma k is the center of the circle, h comma k. And notice, if you're thinking about it, you can think about it as you're taking the opposite, because you see a negative h, so it's h, negative k, so it's k. So so the center is h comma k, and the r, the radius, is r. So that number needs to be square rooted or write it in this form, r squared, and then that base is the radius. So there's sort of the algebraic proof on how we get the formula, and this right here, it's just called standard form. Standard form for a circle. And you could, we're going to look at some other conics, but one of the hallmarks of this is that the x values are squared, the y values are squared, and there's an addition sign that connects them, okay? And we'll get more into that when we start looking at some of the other conics, but we've got the circle here. All right, I think that is what I wanted to say. Yeah, we could also have the general form of that circle, and it's not as helpful because when you have it in this standard form, there's a lot of great things, right? Standard form, there's a lot of great things you can get. Okay, kind of glean from this equation once it's in standard form, right? The blue h and k is our center, and the red r is the radius, so you can draw a circle quickly if you know its center and radius. Okay, so with that, let's go ahead and go up to question number 1. It says the graph of a circle is illustrated to use the graph to find the center and radius. Okay, so we can already see that the center is, right here. And so that center is, h comma k is 3 comma 4. Okay, now what is the radius? The radius is going to be this distance from the center out to this point on the exterior or on that circle. And it's probably easy enough to just count that out. 1, 2, 3, 4, 5. So the radius is 5. If it wasn't that easy, you could do the distance formula. D equals the square root of, and of course the difference of the x's, quantity squared, plus the difference of the y and all that. And that would give you that distance also. But that is our radius. Okay, so kind of reviewing that standard form again, what does it look like? Well, it's x minus h quantity squared plus y minus k quantity squared equals r squared. So already you can see that the r is 5, and if you square 5, you get 25, right? So they already have that right side of the equation done for us. All we need to do is fill out the rest. So it's going to be x minus the x value from the center, which is, so x minus 3, quantity squared, plus y minus the y value from the center, which is 4, quantity squared. And there you go. We've got our first problem done. And let's see what else we have next. Same kind of problem. In this one, they don't give us the center, so, we can, once again, you could use the distance formula on that. I think this one might be easy enough to see. But this all the way across is called the diameter. And what we really want is the radius. So what we really want is half that. Visually it looks there, I better count it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, perfectly half. So that is my center. So my radius is 6. And what is the center? Let's call the center 1, 2, 3, 4, comma 1, 2, 3, 4, 4, comma 4. That's the center. Okay, so with that, we have all the critical information that we need to do this problem. So they're asking for the center. H comma k is 4 comma 4. They're asking for the radius. The radius is 6, right? All the way across is called the diameter, and radius is halfway across. Now we want the equation. Well, notice once again with the equation, right? You have x minus h, y minus k, so that's our center. And our radius of 6, they already squared it for us on the right, so you got 36, so that part's done. The left, all we need is x minus h, which is 4 squared, plus y minus k, which is also 4, the x and y value of our center. All right, so there's that. Let's move on to the next one. There's my beautiful notes. Let's look at this number. Let's see if we got a little more space here. So number 3, it says find the equation of the circle having the given center and radius. Okay, so using our standard form that we developed already, it's going to be x minus, right, our x value from our center, 0, squared, plus y minus our y value from our center, which is also 0, that's quantity squared, equals the radius, 7, and that gets squared. So subtracting out 0 is not necessary to have that in our final answer. So my equation simplified would just be x squared plus y squared equals 49. And you can see whenever you have x squared plus y squared equals, that's going to be a circle centered at the origin, 0, 0. Next problem. So let's do this one. This one says, let's put it in the standard form. So we've got quantity x minus 3 squared plus quantity y minus 2 squared equals, what's the radius? Radius is 5. And don't forget to square that. So that becomes x minus 3 squared plus quantity y minus 2 squared equals 25. And that is our answer for number 4. Okay, what's next here? It's kind of tight space-wise, but I think we can do it. Find the standard form of this equation, radius of 13. Okay, so you don't have to do this step. X minus 0, quantity squared, just x squared, right? Plus y minus. Okay, I'm gonna take a little time on this one, just to show something, and then after you get used to it, you can kind of do it in your head. But this is y minus a negative 5, and I'm kind of showing this with some extra work because I want to make sure you know that there is a double negative going on there. And then that's going to equal my radius squared. So when you see this subtract a negative, of course that's plus, right? So that final answer is just going to be x squared plus y plus 5 quantity squared equals 169, 13 squared. So when you actually look at this, and you actually see that negative 5, that means the y value of the center, the center's y value is negative 5. Remember, it's always opposite. And we notice that with our shifting. Remember our horizontal and vertical shifting? Well, the horizontal shifting was within the parenthesis, which was a horizontal shift, and it was always opposite. So this is the similar thing. And so what's happening here is we're learning how to take a circle from the center and shift it horizontally and vertically. And it's always the opposite of what we actually are identifying in this parenthesis. Okay, let's do the next one. Write the standard form of this one. Okay, well, we've got x, and you can start doing this in your head if you like. The x value of the center is negative 6. So you could say x plus 6 would give me a shift to the left by 6, plus y minus 8 would give me a vertical shift up by 8 squared. And that equals the square root of 5 right there, quantity squared. So what's the final answer? X plus 6 quantity squared plus y minus 8 quantity squared. And when we square root, they undo each other, leaving us just with a 5. Okay, so there is our answer. See if I can put a box around it. Okay, next we switch our gears a little bit by taking a look at an equation and seeing if we could actually graph this. So the pieces that you want to pull from here, of course, would be the center. So what is the center? Well, this equation is perfectly in standard form. So the center is going to be the opposite of what you see here. So it's just going to be 3, 2. There's our center. 3, 2 is right there. Okay, and then what's our radius? Radius might be better found by thinking of 16 as 4 squared. So therefore, it kind of pops out a little better for us. Radius is 4. So all we have to do is go to the left 4. 1, 2, 3, 4 to the right. 1, 2, 3, 4 up. And 2, 3, 4 down. And this should make a perfect circle for us. Not sure if I can draw a perfect circle, especially this side seems really hard to do. It's kind of upside down for me. Gee. Okay, not perfect, but it'll do. You've got these nice points here, right? And, let's do it right now. We can actually run a check. You don't really want to run a check on all points. Now, by the way, the center is not going to be part of the equation. The center is not on the circle. The center is just a nice reference point to help us draw the circle. But if we want to check one of those points, pick a point, pick one of those nice integer points. Like how about, I don't know, you could pick, what's that one, 7, 2. Probably could have picked something with smaller numbers, but that's no big deal. Let's just use that one. And let's plug that back into the original problem. The original problem said x minus 3 squared. So x is, in this case, I'll use purple, x is 7. And then I'm just looking at the original problem plus, whoops, I don't want y there, plus y minus 2 squared equals 16. And what is y? Y is 2, so we plug 2 in there. And we see if we get the left side equal to 16. So 7 minus 3 is 4 squared. 2 minus 2 is 0 squared. 4 squared is 16. And you can see pretty quickly, yeah, that point 7, 2 that we actually got from just taking the center and then using our fact that the radius is 1, 2, 3, 4 to the right, we actually got a point that checked out. So I feel like I definitely have the right answer. And by the way, I do have the right answer. Let's take a look at the next one. Same kind of problem. Let's first figure out what's the radius. I encourage you to write that as r squared. So 16 is equal to 4 squared, so that really helps us to remember the radius is just 4, it's not 16. And the center, of course, is the opposite of what you're looking at here, so it's going to be negative 3, negative 4. Tells us we have to shift left 3 and down 4. Left 3 and down 4 gets us to our center. It says the radius is 4, so we go right 1, 2, 3, 4. Left 1, 2, 3, 4. Up 2, 3, 4. Down 1, 2, 3, 4. All right, and then we're able to go ahead and make that sketch. Ugh. Okay, and so we've got these nice points. If you wanted to, you could check them. Let's move on to the next one. So remember I said somewhere in this video, I know I did, said that when you see x squared, you could think of that as x minus 0 squared. So that's just telling us that the center, h comma k, well, the x value of the center is 0, and the y value is the opposite of that, so it's just 2. So we now have a center. Oh, let's do the radius right now. Man, couldn't they get anything other than 16? So the radius is 4 squared, because 4 squared is 16, so that helps us remember that the radius is 4. So we go to 0, 2, center, 0, what was it, 0, positive 2. That is our center, and I believe it said it had a radius of 4 again. So then all we have to do is go 4 up and 4 down. Am I looking at something different here? Did I check that? Yeah. That was good. I guess I didn't mark that center. -3, -4. Okay, well, we have this center at 0, 2. It has a radius of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Make that sketch. A little sloppier. Sort of the key that you want to do is when you come through this point, you want to make it flat right there and flat there, because what people have a tendency, and look at them, after I start telling you how to do it, I make it worse. But people have a tendency to have a center, they get these points, and then they kind of go like this, and it just starts looking like a diamond or a square. So try to make, one of the keys is understanding these tangent points. And so the circle has to come in, it's got to go flat. It has to have this, it's called a tangent point. So it must be flat once it hits this. It must be perfectly vertical once it hits this. And by doing that, it makes you kind of round it out. And I'm about the world's worst artist, so anyhow. But I know mathematically that that is true. So you could, of course, check some points if you want. And one of the easiest points probably to check would be, I don't know, how about this one right here? 0, 6. Checking is not required, but I think it does help us understand a little bit better what's going on and kind of understand how this formula is working, or how the equation works actually. So that original equation said take the x and square it. What is our x that we're checking? Let me see. We're going to check 0, 6. So we're going to put in the 0 for x. Then it says plus y minus 2 quantity squared. What's the y value? 6. And we're saying that better equals 16 is what we're wanting to check. And so 0 squared is 0. 6 minus 2 is 4 squared. Of course, 4 squared is 16, which equals 16. So yeah, unless I'm just super unlucky or lucky, or however you're thinking about it, that point is right there, but the rest of the circle's wrong. Meaning, like, I mean, what if you had a circle like this? What if that was the answer and you check that point? You know, you'd just be really unlucky. But I feel like for the most part, that's a real good check. It's not perfect, but it kind of gets us. You could check more points if you're worried about it. You could check all four of those easy points, and then you'll know pretty much for sure. Let's take a look at number 10. Well, this is not good. Well, look at that equation. It is in something called general form. And we don't like a general form, because general form can't just look at it and pull out the center and the radius. So we want it to be in standard form. So we're going to take this guy and think about standard form, right? What does standard form have in it? It has a perfect square with the x's plus a perfect square with the y values equals r squared. So, well, we're going to have to complete the square, right? Perfect squares are completed squares, right? If you don't have a perfect square, you got to complete the square. So I'm going to take this and I'm going to organize it in a way. Let me tell you how I'm going to organize it. I'm going to group all the x's together. So how about x squared minus 2x? So I took x squared minus 2x. I'm going to leave a space because I need to complete the square. And then I'm going to group my y values, any term that has a y in it. So y squared right there. And then 6y plus 6y. And then I'm going to leave a space because I've got to complete that square. And then I'm going to set it equal to, well, I'm going to subtract 6 on both sides. So I got a -6. And I'm going to have to add whatever I added on the left. And I'm going to do that twice, right? So, do you remember how to complete the square? Let's take a -2 to complete the square. Whoops, I'm supposed to change colors. Let's take -2. What do you do to it? Divide it by 2 and square it, which equals 1. So 1 completes the square. If I add a 1 on the left, I have to add a 1 on the right to justify, to keep the equation balanced. And might as well finish this off. It's now a perfect square. So what does it factor down to? X minus 1 squared. Ooh, right? Look at our formula, right? Our standard form has that perfect square look to it. Let's do it again here. And there's our linear term that we always focus in on. 6 divided by 2 is 3. Square that and we get 9. 9 completes the square. If I add 9 on the left, I better add 9 on the right to keep the equation balanced. And we can see that that is now a perfect square. So that factors down to y plus 3, quantity squared. And on the right-hand side, we have what's that? 1 plus 9 is 10. 10 minus 6 is 4, right? It's 4, which we can write as 2 squared if we want to graph it, which we do want to graph it, right? So this is 4, so why don't we write this as 2 squared? Okay, so let's pull out the information we know. What is h? H is the opposite of that, so it's 1. What is k? The opposite of that, so it's negative 3. What's the r value? Well, we wrote it as a perfect square, so r value is 2. Let's go ahead and go over here and graph this. 1 comma negative 3. 1 comma negative 3 is our center. Our radius is 2. 1, 2 up, 1, 2 down, 1, 2 left, 1, 2 right. Let me go ahead and see if I can graph this, or sketch it. Jeez. Okay, so there's the circle, and since I had to complete the square and do a bunch of stuff to this thing, I really kind of want to check it. So why don't I check it with a point that's on that circle? How about that one? I'm sure we could probably find an easier point, but anyways, that point's just 1, 2, 3, comma 1, 2, negative 3. So we're going to use 3 comma negative 3 to check. And what's the original problem? The original problem said take x and square it. What's the x value? 3. Plus the y value, which is negative 3 squared, minus 2 times x. X was 3. I guess I should do another color for that one too. So y was negative 3. And the formula continues on with saying 6 times y. Y is negative 3. It says plus 6, and all that better equals 0. If 3 negative 3 is truly a point on our circle. So 3 squared is 9. Negative 3 squared is 9. Negative 2 times 3 is minus 6. And 6 times negative 3 is plus a negative 18. And then I got a plus 6. So you can kind of see that when I add these two together, I get positive 18 and negative 18, so that zeroes out. And a negative 6 and a positive 6, that zeroes out. And I'm left with a 0 on the left, which definitely equals 0 on the right. That definitely is the correct point, and I'm pretty sure the rest of it's right. I would have to test a little more, but that is correct. Okay, so let's take a look at the last problem. Same kind of thing. We're in standard form. We're in general form, and we want to be in standard form. So we go ahead and group x squared plus 4x, I leave a space, plus y squared plus 8y, I leave a space to complete the square. I'm going to subtract 4 on both sides of the equation. So I got a negative 4 on the right. I know I've got to add something to justify my completing of the square. So we start off by looking at this term. Coefficient in front of the x to the first power is 4. We cut it in half. That's 2. We square it, and that is 4. So 4 completes the square for the x values. We factor it, and we get x plus 2 quantity squared. Then we go ahead and complete the square for the y values, and we take this 8 cut it in half, which is 4, square it, which is, square it, which is 16. And so 16 is the value that completes the square. Now, before we really screw this up, I added 4 on the left, so I have to add 4 on the right. I added 16 on the left, so I have to add 16 on the right side of the equation. Okay, now y, the y terms will factor into y plus 4 quantity squared. And on the right-hand side, we get a negative 4 and 4 is 0, so we're left with 16. So this whole piece becomes 16. And I think it'd be a good idea to write 16 as a perfect square, 4 squared. So now we can pull out all the information that we need. We can see that the x value is going to be the opposite of that, so negative 2. The opposite of that, so negative 4. And the radius is 4. Let's go ahead and graph negative 2, negative 4. Okay, try that again. Negative 2, negative 4 is right here. That's the center. And this has a radius of 4. They really sure do like that radius in this book, in this program. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Put these little lines to guide me. Let's see if that actually helps. Yeah. I'm not satisfied with my work. That is not my best work, but that's going to have to do. There's the center. We said that center was negative 2, comma negative 4. And let's go ahead and test a point. Let's test a point. Get rid of that little thing. Let's see, I want to check. What happened to my pens? There it is. I want to check. How about that point? Negative 2, comma negative 8. Negative 2, negative 8. Anybody else see a better and easier point to check? Maybe, how about, yeah, that looks easier. Doesn't that look easier? 2, comma 0. Sorry, that's negative 2. That's negative 2, comma 0. Negative 2, comma 0. That looks easier. Let's scratch that one. Since we could pick any one of those 4 nice integer points. So what was the original problem? I'm not going to use all the color this time. The original problem said take the x and square it, so negative 2 squared. Take the y and square it, 0 squared. Plus 4 times the x, negative 2. Plus 8 times the y, 0. Plus 4, supposed to equal 0. So negative 2 squared is 4. This is 0. This is a minus 8. This is plus 0 plus 4. And you can see we have this. We have 4 and 4 makes 8. And of course, 8 and negative 8 zeros out. So we have just shown that that point is definitely a point on our circle. Makes us feel pretty good after we did all this, completing the square twice. And that is it for 9.2. And I hope you're having a great day. Don't have any more? Okay, good. That's it. Hope you're having a great day, and we'll talk to you soon. Bye.